Okay, now let's proceed with the third part of this chapter, that is static of particle. Okay, this is the title of this chapter, static of particle in two-dimensional. What is the meaning of this is a particle is said to be equilibrium if motion does not take place when it is act by two or more forces. So static here is means equilibrium, means the resultant force is zero, so the particle remain at rest or remain stationary. So this is the keyword. So the resultant force is equal to zero. Okay, and two-dimensional. Two-dimensional is depend on the coordinate of the forces. So for example, if one dimensional is only consider one axis, for example x-axis, and then for two-dimensional is consider plane. So plane that's on the y and x axis, for example, and three-dimensional, it's consider all the three axes, the x, y and z. So for this chapter only consider force in the plane. It is consider the x-axis and y-axis only. So equilibrium of particle, as I mentioned before, is the resultant of all forces acting on it equal to zero. So the total force equal to zero. That means the because it's considered the x-axis and y-axis, so total force at the f-axis is zero, and also total force at the y-axis is zero. So there are several methods to get the resultant forces. There are, okay, the resultant forces is total of fx squared, and plus total of fy squared, square root of this. So the resultant forces of the system, you can measure the resultant forces by this formula, and to know the theta r, the forces that the resultant, for example here, for example if you have f1, f2 and f3, and then after you by using this formula you get the resultant forces, and then for example the fr is here, fr, the resultant forces after you add all of these forces. So theta r is here, the from the x-axis to the resultant forces. So the formula to get this theta r is tan theta r equal to summation of fx over summation of fy, or theta r equal tan f1 fx over fy. Okay, there are three methods to solve to get the resultant forces. And the first one is graphical method, trigonometry method, and rectangular method. Okay, for example, I will show you how to solve by these three methods by using this example. Determine the resultant force resultant of the two forces. So we have 150 Newton and 100 Newton here by this angle. So how to solve this? By using these three methods. Okay, the first method is using graphical. Graphical for this one is manual drawing that using scale. So we rarely use this method, but this is one of the method to solve the resultant forces. So by using this method, so you need to draw the based on the equation given and based on the force given in the question. So we have 150 Newton here, and then we have 100 Newton here. So this is y-axis and x-axis. So based on this, for example, you can use the scale of 1 centimeter equal to 50 Newton. So 150 Newtons, you need to use 3 centimeter. And 100 Newton equal to 2 centimeter. So you measure this and then this angle you need to use protractor to measure the angle. So you need to be accurate angle. So you will get, for example, here 150 newtons, and then another one is 100 newton. So based on triangle law, the resultant is opposite direction. So from these forces, the 100 Newton is toward this, and this is tail head. So this the resultant is another direction where the head meet the head and tail meet the tail of the forces. So this is the resultant forces, and this is 30 degree and this is 20 degree. So the resultant here, you need to use ruler, and then based on ruler you get 3.3 centimeter. So 3.3 cm you need to multiply by 50 Newton. So you will get 165 Newton using ruler. And then the angle is from the angle here is delta R, that is measure from x-axis. So from x-axis here until the resultant forces. So by using protractor, you will get 83.5 degree. This is the first method to solve the resultant force. Okay, the second method by using trigonometry. So trigonometry is by using Lami's theorem. So previously the graphical used triangle law. So this trigonometry is based on Lami's theorem. So the formula for Lami's theorem is sin A equal to A, sin A over A equal to sin B over B. So the angle here is this is B small b, this is capital B, and the cosine rules is A here and cos A here. So BC, BC. And this is the formula. So how to solve it? Same like before, but the drawing is not on based on scale. So you just draw 100 newtons and 150 newtons here with the angle, and then you will get the resultant forces toward opposite direction. So okay, for example here, this is beta. So based on the formula, this is cosine formula. That's for example here, this is we can okay, this is R. So R squared. So this is based on the formula R squared equal to, for example, this is A, this is B, equal to B squared plus A squared minus 2 BA cos beta. Okay, this is the formula based on cosine formula. So you already have B 100, and then you have A 150, and you have the angle here. Angle that is opposite to the R is beta. Okay, this beta you need to measure based on trigonometry, because you have 30 degree here and 20 degree here. So based on trigonometry, so this is 20, and then this one is 90. So 90 minus 30 is equal 60. So you get here 20 plus 60. So that's why the beta is 20 plus 60 equal to 80. So use cos 80 here, and then you will get the R equal 165.2 Newton. This is only resultant force, and then you need to measure the alpha here. Okay, from this data. So this is alpha, because this is beta, alpha, and another one is theta. So based on this is cosine rule, and this is sine rule. So based on sine rule, you use sine alpha over 150 equals sine 80 over 165.2. So by solving this, we will get the alpha 0.4, but this is not the end answer, because the theta is measured from the x-axis. So you need to plus 20. 63.4 plus 20 equal 83.4. So you will get the answer here. This is based on trigonometry method, and the third one is by rectangular method. Rectangular method is based on the principle of independent physical principle. That's from the resultant we have the force at the x-axis and y-axis. So for this method, you use cos. You use cos for fx and sine for fy. So for each forces, you can divide it into x axis forces and y axis force. For example, 100 Newton, the fx is 100 cos 20 Newton and Fy is 100 sin 20 Newton. Same as this one. Okay, for this one is a bit different. Okay, because here Fx is cos, Fy is sin. But this one, it's use Fy is cos and Fx is sin. Okay, why like this? Because okay, the angle is at here. So you the angle is 30 at the y-axis. So that means the cos is to get the force at the B side. That means at the side of the angle. So this is 20. At the side of this angle is you can use cos. Same like this. So side. So but you also can solve another method. For example, here this is 30, so this should be 60. So this angle will become 150 Newton sine 60 and 160 Newton cos 30. Actually, this answer will give the same answer. But you need to make sure that if you want to use this formula, this cos theta and sin theta, cos for fx then sin for fy, the angle should be from the x-axis. But if like this, you need to get the if you want to use this formula, you need to get the angle at the x-axis. Okay, so this one okay, and then for the resultant forces at the x-axis is 100 cos 20 Newton, okay, here, minus 100 sin 30 Newton. Okay, this one you can use sin 30 or cos 60. It's same. But what I want to highlight is negative here. Okay, why negative, not positive? Because when you expand this force from this one, it will expand toward here and toward up. So here the x-axis is positive, x-axis is here toward right, but this force is toward negative, so this is negative x-axis. So that's why we need to minus it. Okay, we need to minus it. Then when you solve it, you will get the Rx is 18.97. So this is plus. So plus mean is toward right. Okay, for the resultant of Fx, 100 sin 20 Newton. Okay, here. Okay, this one 150 cos 30 Newton is toward up also. That's why it's also positive. So after you add, you will get the positive direction, so it's toward up. Okay, the resultant force at the x-axis and the y-axis is not the end answer. So when you already have the resultant force, you need to solve this means the resultant forces, the total resultant forces, by using the formula rx squared plus ry squared square root of it. So when you solve this equation, you will get the answer of resultant force is 165.3 Newton, and then the theta is tan negative 1 Fy over Fx. So you will get the theta is 83.4 degree. So by using three method, there are a bit this means the answer is not similar for all method, but it's almost similar. So we have 160 something for all the answer. So this is how to solve the resultant force.